I'm currently, as of last week, an engineering manager at Tats Group. Sure. So a lot of people know me. I was at Redify for a while, little consulting company. I don't know if anyone's heard of them. And Octopus before that. And I've recently joined Tats, for which most people that know me went, really? And yes, really. So Tats is an interesting company. Where to start the Tats story? So who's heard of the Tats Group? Who thinks of them as a really fast-paced, dynamic, agile environment? Yeah. Sorry. Turtle. So Tats is an organisation that is undergoing this big agile transformation at the moment. Very much changing the way they work, which is kind of interesting to see. And if anyone's kind of been familiar with that, I sort of walked in there as a consultant 5 years ago and walked out half an hour later going, nope. So yeah, at the moment there's this big change going on, and really trying to change the way things work and get stuff moving. So I've joined as an engineering manager to, there's kind of top level buy-in of this is what we're doing, and there's sort of developer level, yep, cool. And there's a whole bunch of people sitting there going, right, what do we do next? So that's what I'm doing. Sorry? Lots of things. So I'm the engineering manager in the lotteries group. So anything to do with. Excellent.
That's what he's doing tomorrow.
Yeah, that's what I'm doing tomorrow. That's right. Yeah, there is a lot of work to be done, and it's good fun. So, if anybody is interested in joining me on this journey, Tats paid for your pizza, by the way. You can thank Shaw for organising that. Yeah, we need people. So, if anybody is feeling like a change of career, job, definitely come and see myself or Shaw if I'm too scary. We need .NET people, desperate for some mobile people. C++ people that can talk to people, also good. Yeah, he's at home. Yeah, we need UX people, we need PMs, we need BAs, we need all sorts of people. So if you're looking for a change of job, or you know somebody with any of those kinds of skills, send them to me. Actually, come to me either way, whether you think you might be a good fit for Tats or not, because there's lots of people hiring in Brisbane at the moment. I've kept Chris quiet for 30 seconds. 6 Pivot hiring, so there's lots of people hiring at the moment, and I've spoken to a lot of them in the last couple of weeks. So, if you are thinking about something and you want some advice, come and talk to me. But yeah, definitely, if you know any mobile developers, I could use some yesterday. So yeah. So, in my first week in this new job, I've been walking around and sort of talking to a lot of teams who are all sort of trying to get going. All right, we want to do, agile, we want to be agile. And there's a lot of focus around DevOps and automation, and who knows Shaw? A few people know Shaw. The Shaw's done a lot of work of getting stuff automated, and there's a lot of people wanting to get on board with that. They want to be able to ship more regularly. And so there's a lot of discussion at the moment around testing, because one of the first things you've got to do is you've got to automate your tests, right? Who does integration tests? A few people. Who's half? Who does kind of like UI functional testing? Yeah, about 3 people.
You mean manually?
Sorry, yeah, manually. Yeah, exactly. Who's doing unit testing? Yeah, cool. Who's doing full-blown TDD or BDD? Yeah, 4 people, 5 people. Cool. So there's a lot of discussion around testing, and pretty much, every room that I've walked into, there's a discussion around test automation, test architectures, test environments, test databases, test environments going down, test databases being too big. Has anyone kind of hit those kinds of problems where you're like, just that? I know you have. Cool. So the sort of what brought this talk about was, one of the things that I've picked up on, this really common theme, is struggling to get test automation to happen. And so I blatantly, stole a bunch of ideas. No, I didn't steal. There's a couple of things that I've been having discussions with people about. From this guy. Has anyone seen this guy, read his stuff? No? One person. And well, you can go. But I've kind of been trying to summarize this stuff, and it's this whole blog series. But it's kind of, 7 years worth of blog series, and I've been trying to summarize it to people. And I thought, well, this would make a really good internal talk to get all the test teams together. And so when Damian said, hey, look, we need somebody to speak, I went, hey, look, I'm writing this talk anyway. I could come and give it to you guys. So here we are. So integration test. Now, something that has happened on this blog is he's changed the wording to integrated tests, because basically the test community got really upset with their definition of what's an integration test and what's an integrated test and what's a functional test and what's a, test people love debating that stuff for days and days and days. So he's changed it. He actually pulled me up on Twitter. He said, actually, it's integrated tests. And I went, yeah, but the original title is so much more provocative, it will get people in the door. So clickbait, yeah. You won't believe what happens next. All right. So what's the problem with integrated tests? Who's built something like this? Okay, a few people. So, say we've got this app, we've got some presentation layer on the top. We have our business logic layer, because that's what the architecture diagrams from Microsoft circa 1996 said we should do. Sorry? No, it's stored procedures, actually. Had a stored procedure argument with somebody today. That was fun. It's like, what year is this? Sorry. No. And then oftentimes we'll build, a system, particularly in bigger organizations, where we've got some other thing, commerce server. There's only one person that remembers that. Some other system that has some API on it, and our system builds on top of that. And I'm sure pretty much everyone's kind of had to build some big application on top of some other big application, and the fun that's involved there. Is anybody not? Cool. So we're all sharing in the pain at this point? Excellent. Excellent. So say we build, and you might have some of your own data there as well. So something that we can all sort of understand as, an e-commerce system. So this is when your testers come and sit down and they go, right, we've got some test cases here. We need to sign up a customer. We need to log in a customer. Customer needs to view their details. Customer needs to update their details. You need to have a support person or an admin go and find a customer and update their details and view their details. And then, we start to go, right, we've got a logged in customer and they add something to their shopping cart. An anonymous customer adds something to their shopping cart. The anonymous customer turns into a known customer once they log in at the checkout. And then they add an address at the checkout, right? And on and on and on and on and on, We all have testers with, thick documents of test cases. Yeah? Excellent. So then, we sit down and we go, okay, we need to write some tests. So, we need to write some integration tests. And what typically happens is these tests start to span our code from, either the top presentation layer or our business logic, and then hook through to this API in some test environment. With me? Has any people done that? Nobody's done that? Has anybody done that? Come on, work with me. Or is just no one willing to admit it because they dropped it halfway through?
You got halfway and stopped?
Halfway and stopped? Who got halfway and stopped? Sorry? Well, you can go home. Exactly. But if you need to verify does your system work, then you need to go through and go, well, we need to talk to this third party to know if our system works. So you figure this out. Sorry?
I've used a third-party API in their live environment.
Yep.
And they accidentally ship stuff.
Yeah, shipping against seen that. So, so we started to build these tests, right? And, then we hit a whole bunch of problems. We have test environments. Who's had a problem around test environments? Yeah. Awesome. The test environment's down, test environment doesn't look like the production environment. Why not? Because we have test data issues. Either, it's just utterly broken, or we've got, or it's 10 terabytes, or we've got to take all of our live data and then scrub it all because we've got people's details in there because we wouldn't want to expose that to the world. And then we have test data that leaks between tests. So, you might run a test which updates some details, and then the next person that runs the test goes, he's not called John Smith anymore. Test blows up. I see a few nodding heads. We hit that one.
I have to go through reports to find an account which matches the exact criteria.
Yeah, right. So then, to fix that, we do things like, as part of our test run, we will restore a test database from backup and, put that there so we've got a known set of data, right? Who's tried that trick? A few people? And then, of course, tests run really, really quickly when we're restoring, 6 gigabyte of database for every test run. And then, of course, we have to maintain all of our test infrastructure, test stand-up and backups and stuff like that. So, a few people have done that. That's fun. And then because of all that work, that not only the sort of server infrastructure, but the stand-up, tear-down code, do we roll back a transaction? Do we, to get that all right, load test data in? It takes a whole bunch of time writing tests. Yeah? And once we do that, then we go to make a change to our application, and we've broken all of our integration tests, so then we have to spend all the time refactoring tests. And basically, it's a giant nightmare. And that's not to mention the other problem of just the number of combinations, of things that we have to test across two different systems. And this is kind of the, a big part of the original blog series. There's just so many different scenarios we have to write. So it's a nightmare. So what typically happens that I've seen in these organisations, if they manage to get started down this road, they stop. So you stop maintaining your tests. Who's started with a really, we're going to test all of this stuff and then kind of stopped partway in? A few people brave enough to admit that one.
2 or 3 times?
2 or 3 times, yeah, a day. So we stop maintaining them. Once we stop maintaining tests, what happens? We stop trusting them. Okay? They get deleted. We stop trusting the tests. Yeah. Yeah, they get commented out. Yeah, I worked on one group where they were obsessed with test metrics, code coverage metrics. But when we got closer to a release, we realised that a whole bunch of our logic was wrong. So the team lead just commented out the assertions. So we still ran the test. We still covered the code. We just ignored the result. Nothing to see here. These people walk among us. So we stopped trusting them. And once we stop trusting them, then we stop running them. Okay? Once we stop running them, hands up who hasn't said that. Yeah. So everybody has said this. I don't know, I just thought that was funny. Every developer ever has at some point gone, that's a really easy change to make. I'm just absolutely petrified of doing it, and then you're not in a good place, because that's where we want to be, is where we can go, yep, cool, we've made the change, we're confident to ship it, so that we don't have, a 2-month-long regression manual test cycle, which is the kind of opposite of the agility that we're trying to get to. Right? There's a few people going, yeah, we know this, and I apologise. Like I said, this was something that I was going to sit down with a bunch of testers to do, but I got roped in. So anyway, okay, so we get it. What do we need to do? And this is where it's important to ask, what is it that we're actually testing? If you ask a tester this question, what are they going to tell you? Pages 1 through 47 of the test plan, yeah. What do we need to test? You ask a tester, what do we need to test? What are they going to say?
Negative 1 BS. X, Y, Z, and Y.
Everything, the whole system. to a tester, it's like you test the system. And this is where the mind shift is, and this is the kind of conversation that I've been having. It's like, well, let's look a little bit deeper at that. If you actually understand the system, what we're really trying to test, and if you know this, and I do apologise, you can steal the slides later on and use it to beat a tester up. Really, most of what we're testing is our code. The integration is a very, very, very small piece of this. Like, does it talk? Does that thing talk to that thing? Really what we want to test is our logic. But the problem is that we have this massive combination between our system and, some other system. But if you look at that massive combination of stuff, that kind of initial set of test cases that I said, if you were to look at it, it's generally a fairly small set of functionality from the other system. Okay, so think about that e-commerce example. We've got a customer logging in, customer viewing their details, and generally the test is going to have to log a customer in, then view their details. Really, the API might actually be very, very simple. Look for customers, get a customer, update a customer. So customer logs in and adds an address. That's probably one call to another system. Yeah? So we spend a lot of time writing all of these complex tests that test their interaction with another system, whereas in actual fact, the actual number of combinations of, the combinations are huge, but the actual interaction with the other system is quite simple. Yeah? Make sense? This is mind-blowing to testers, by the way. So if we can assume that third-party system works the way that we think it actually works, we can do a lot more local to our code, right? Make sense? This is where contract tests. Who's heard this term? Contract tests? A couple of people? Yes, this is where this idea of contract tests come in. Where we had this really complex thing where we've got all these test cases that need to interact with, some third party that we don't necessarily have control over, or we have to manage all this test data. What we can actually do is write what we call contract tests. So that might look like this. We might have this system, and we can write a really simple test harness around it that answers these questions. Can I find a customer? Can I load those customers' details and view them? Can I pull them out? Can I update them? Yeah, kind of very small set of questions that we actually need to ask against that. And with that, we can basically test our assumptions about that system. And we can say, right, are the things we think about this system still valid? And the nice thing about that is we don't actually need to run that with every build. So at the moment, you have all these teams and they go, right, I've checked in one line text change to this app. Now we need to go and restore 10 gig of test data, scrub it all, run one test, tear the database down, stand the database up, run the next test, tear it down, stand it up, run the next test. An hour later, you might have a build pop out the other end. And that's, kind of horribly tedious and slow. And that's where you go, oh, look, this is going to be too hard. Let's just jump onto the prod server with Notepad and fix that test right up. So, if we kind of isolate this contract test, we actually don't need to run it with SEI build. We can run this thing nightly, daily, weekly, depending on the other system. And if you've written some kind of library or wrapper around it, this is a really good way to test that piece. We can use that piece to run that. So the idea of this is if we can verify all of our assumptions about this third-party system, then we can assume that our code will work, right? So we can say, right, our code will work given that this system, if we ask it this question, will give us this answer. Once we're confident that that happens, we can work a lot more locally. So then, our test starts to look like a bunch of unit tests around here. Maybe some unit tests around our presentation layer. If we're using Angular or something like that we can, put some tests into our presentation logic, some testing around our business logic. Then we still got 100% coverage, really. Well, as close to 100% as, probably closer to 100% than you did before, just in a different way. And this is kind of mind shift for a lot of, people testing. It's like, well, I need to test the system. Whereas actually, you can test a lot more locally, providing you assume, because we don't go, oh, look, we need to put a whole bunch of integration tests on this operating system. We assume that the operating system works a certain way. If we try to write a file, it's going to write a file, usually. Yeah?
Have you encountered El Capitan?
Yeah. Yeah, the words came out of my mouth and I thought of all the edge cases where actually writing a file is very hard. And I went, yeah.
How do you deal with those edge cases though? Because if you're doing your contract testing,
Yep.
there may be edge cases that you didn't do in your contract test,
Yep.
and then they'll never show up because you've assumed that it's internally consistent under all conditions.
In terms of like writing a file or...
Oh, well, you run against your contract, but your contract is actually a better system than the real system. It actually performs consistently, and the edge cases are not in there. How do you find
So then, so we'd probably... I might actually come back to that, actually, because that's really interesting. Because, let me come back to that, because let's get into that, because this is going to go very quickly. So at this point, our contract tests are a lot less affected by the changes to our application code. So, if we write, if we want to go, look, say we started out with just, I'm a customer, I want to view my details, and then we have, hey, look, I'm an admin and I want to view someone else's details. We don't have to go and write all those integration tests again because we've kind of got it covered. So our application can add that stuff, and our contract tests will say, yep, we can still load a customer. Doesn't matter how you want to look at it in this system, we can still load it over here. Our contract tests are going to be a lot less brittle because they're written once. Any code you don't have to write is good code. It's just there, it just sits there chugging away. Our contract tests are going to need a lot less maintenance. So we can change our application code and be really, really agile with that. But really, we've written this one wrapper to get somebody in and out of a, whatever system. So it's going to need a whole lot less maintenance. They're going to be faster. Everything's going to be fast. The contract tests are going to be fast. Can I find you? Can I pull something out? Can I update it? Yep, cool. We run that every night. It's going to take 5 minutes. We're all good. Because of that, our contract tests are going to require a whole bunch less test data management, because you could write a test that says, find a customer, pull it out, update it, did the update stick? Yep, cool, set it back to what it was. You might not actually need this whole stand-up, tear-down of test data thing at all. Which means, a whole bunch less test environment wrangling, a whole bunch less, every test run we spin up a VM with the thing on it. Our chef scripts pull everything down, provision a commerce server, and then go, yep, cool, that worked. So a whole bunch less work. And then what we can do is, because we still do want to test that integration, but that integration was only maybe 5% of the system. So then we can have something that goes, cool, so we've tested this third-party system, we understand it works the way we want it to work. We've got a whole bunch of unit tests around our app. So, we're pretty happy that our app works. And, then we can just go, look, let's have a couple of sort of smoke tests. Does it all work together? Make sense? Anybody think I'm crazy? Sorry? Non-related reasons. Yeah, so I mean that example, if you actually had something that's like, right, this needs to atomically write to a file system and handle all those things. So, I mean, that's a very kind of specialized thing. And so if you had some driver or library or whatever that handled that, can we atomically write to a file system, or can we deal with network connectivity issues or whatever, that would be a library that you could then test in isolation. So if you've got, say it is, I need to atomically write to a file system, but that code is scattered throughout every one of your application logic tests because you're kind of testing from top to bottom, then you're probably not going to put it under the condition where it hits that issue. and you're going to spend, this is kind of mixing of concerns. Here's this, can a customer log in? And by the way, while I'm at it, what happens if there's a race condition on the file system? So that test is going to be really hard to maintain because it's doing too many things. So you would write some kind of driver layer over, the file system because we need to atomically write under it. And then you can write some really specialized tests just on that library to go, well, what if we hammer it with 1,000 concurrent threads trying to write to the same file and whatever else. So you can go, right, our library that does this thing, yep, it works because we've tested it under some load. See, a lot of people go, right, we need a load test environment because we need to put the whole system in there and shove it under massive load. Whereas you might be more effective, go, look, that system works in itself. The bit that struggles under load is this tiny bit. Let's go load test that and then go, cool, we know how that handles under load. Our assumptions are true because we can kind of load test that every night. But load testing, that component is going to be a lot cheaper than load testing the entire system, right?
Well, what happens if, it all works in the tests and everything, and then you put it into production, and then it falls over at 5 p.m. every Friday?
Then you fix that problem.
But you wouldn't.
At 4:59.
How would you discover that though?
Sorry?
Using this kind of approach.
Or how would you discover it? The 4:59 on a Friday problem, you're only going to discover at 4:59 on a Friday.
But you'd discover it if you were running CI against the entire system, right?
Not if the problem was the load at 4:55 on a Friday. So you could spend a year designing every possible test case to every possible edge case you can think of. And then you could spend the next 3 years writing those tests to cover every possible edge case you think of. And you know what will happen at 4:59 on Friday? The edge case you didn't think of.
Yeah,
and that happens every time.
That's
and
exactly what I'm thinking about.
Yeah.
With the contract testing, your hidden assumptions about the contracts.
Well, so the contract test says, right, this thing behaves the way that we want it to behave. Once we've got that, yes, cool, they haven't changed that system overnight, so we're still good. Then you can concentrate a lot more on your application logic. Those weird performance bottleneck edge case things that happen at 4:59 on a Friday, you're only ever going to find them once you actually hit production.
That's what users are for.
That's what users are for, yeah. I've seen there's a few people in this room that have seen code that failed on a Tuesday. All the tests failed for a particular system on a Tuesday. People sell things cheaply on a Tuesday. And tests would fail on a Tuesday because it was all, top to bottom, this thing, and it wasn't, let's take our pricing logic out into this separate component and we can say, right, let's call it with the date parameter of a Monday. Cool. Let's call it with the date parameter of a Tuesday. Because it was a top to bottom thing, you couldn't actually get a green build on a Tuesday because the pricing changed. Unless somebody changed the config file, which...
And then it would break on a Wednesday.
Then it would break on a Wednesday. Turtle!
At what point do you just trust that your third-party libraries are sufficiently testing all those edge cases anyway? Because you've got to come to a point where you realise it's ridiculous trying to test all those minuscule edge cases for your third-party things anyway. I can understand testing a contract, the API still being the same. But
I wouldn't suggest testing every third-party library. If you've got to assume that a library has its own set of unit tests, and if you've got it, it's come off of a green build. But I mean, how often have you had to go and integrate with some product? And the first thing you do is, file new project, some little console app, and just poke around their thing to go, yep, cool. So if I call it like this, I get, it's a customer. Yeah, that looks about right. You can kind of build that exploratory code to go, how does this thing work? If you built that into a test harness, you can stick that in a nightly build and go, yep, Salesforce haven't changed.
Yeah, but that's testing your contract. That's not testing
Yeah.
edge cases.
Yeah, sure.
Another thing, something you'd know, the realestate.com.au guys come up with this thing called Pact.
Yeah.
That sort of
It's a library around building contract because they've got a very sort of microservice environment where they might have 100 services with REST endpoints, and so team A wants to know that its assumptions about all these other because it's a great example. So anywhere where you kind of have these kind of REST-based, microservices with really small teams, really, really agile, you don't know, if the team over there has decided to remove, change their schema, whatever, on you overnight, because that can happen. And, trying to, in that really fast environment, if you had to have 1 million meetings every day before anybody changed, anything, well, then you end up in a similar place to where Tuts might be. Which is, we don't want to change it because we're not quite sure who's relying on us. So this way you can say, hey, look, we can, and I've not been inside REA, but I imagine they have, look, we've got a canary build of this new service, and you would probably run your contract tests. So what he was saying is packed as a library that, is it Ruby or Java?
It's Java. but
Java? There's a .NET port of it as well. Was it npacked or packed.net or?
I can't remember. Neil Campbell made it.
Right. So yeah, a library to go and test, and packed is an appropriate name. It's like, look, this thing works the way we think it does. So I imagine somewhere like that, you would say, look, we've got a canary stream of these services and our production stream of these services, and they probably have both of them in production at any time. But you could then run your contract test against both and go, right, with current production, it works the way we think it is. The thing that they're going to release tomorrow, actually it doesn't work the way we think it does, raise some alarms. And they would probably have some phasing thing where if you put a new version of a service out there, you've got some grace period where, you support the other one as well for a couple of days or a week or whatever like that.
So if we're contract testing this third party,
Yep.
what's the difference between that and contract testing our data layer and then contract testing our business endpoints and then our whatever else endpoints?
Well, you're absolutely cool. I mean, it does depend on the environment and the size of the team. If it's a 3-person development team, you probably don't need to contract test your own database because you're going to go, hey, Damian, I'm going to make a schema change now. But, if you're in a bigger organisation where there are lots of things and, you're not necessarily sitting next to the person who owns the other thing, or you are integrating with another product, then it starts to make more of a difference. So, so what tends to happen you have these kind of end-to-end tests, and anybody changes anything and the whole world breaks. And as a result, nobody can change anything because you break all the tests.
So is part of the problem that unit tests tend to start getting bloated and don't mock things enough? Is that kind of the point as well, or is it? That's
a whole other issue. Yeah. So.
Really that you're just trying
So bloated unit tests are generally a symptom of the code you're testing trying to do too much. Yeah. If you've got a set of unit tests that has this much setup code for a one-line operation and assertion, and then this much teardown code, then either your unit tests aren't factored out nicely enough, or the code that you're testing is trying to do too many things. So, a unit test with that much setup is a bit of a code smell, and you go, we need to refactor something here, whether it's the tests or the system under test.
But it could also be a one-line unit test, which
Yep.
is call this service point, and then that's just got this monolith behind it. Whereas you're sort of saying that doesn't sort of belong in the unit test of.
So a good point, a good kind of decision point there is we've got this test and it runs every night. But all of our builds just failed because that system went offline. Because somebody unplugged the test server. If you've ever hit that point, then it's like, well, we've got some code that we know works, so we need to get a build out, but our build doesn't work because somebody over here just had to do some maintenance on their test database or whatever. So yeah, I mean, in your situation, you rely on a third party, and you've got code that talks to that third party.
That happens to be very
Unreliable and subject to change.
Yeah.
So if every one of your test runs relied on that, your tests would be very, very, very slow. It's just that and fail a lot. You've separated your architecture, and I know this, to go, right, the code that talks to that is over there. So it doesn't, affect the day-to-day tests on, say, your website. So you've kind of split your system out to do that.
So is that packed idea like in a large organisation like say TAPS or some other with
Yep.
lots of different groups doing different things, rather than having each group build their own contract mock of a system, you have each group produce their own?
So packed is to test that, hey, all these assumptions we make around the world around us, they're still true. So you can say, right, we want to talk to this service like this, and it will call it and go, yep, cool, we're still good. So now you can get on with testing your code.
So each group publishes like a test kind of version of their service? Is that what that
No, so would be actually call their test thing.
So group A would test.
Group A would say, here is our staging instance of this service, and you could run some tests against it to go, yep, cool, it does what we want. Now we can get on with our stuff. What you're saying is, once you've kind of split this up, once you've taken something like this on, you go, right, we no longer need for our system to talk to the mainframe, what we assume about it. Then you might have a group that says, well, cool, now that we can assume that this thing has, then you've got to mock it, right? And that mock could be something you just do in code, or it could be something that you do stand up as, look, here's a service that looks from the outside world the same as that one. It's just something that you kind of feed it via config. Here's a file of the test data that we expect that's 100 lines long. If we ask you this question, respond like this. So you can kind of take a mocking approach, but build that into some RESTful service or whatever. So a lot of companies will publish, look, we've got our service, it's here. But if you want to just totally fake it out, here's a pretend one, so that may work depending on the architecture. You may actually be tightly coupled to actually calling some service endpoint. You want to call a service endpoint and go, did you get called? So you can kind of mock out that service endpoint stuff, but it's not against some massive monolithic database all the time, because you go, look, we've got some other test running here that goes, if I ask you for a customer, will you still get me a customer? Cool, excellent. While we're happy with that, I can just use my fake one.
So it gives you confidence in your mocking.
It gives you confidence in your assumptions. So if you've got confidence in your assumptions about that system, then you can write your own mocks based on that assumption.
Yeah.
So if I know that if I ask you what day is it, you're going to say Tuesday, then I can write some code over here that says,
And you don't have to keep asking me what day it is.
Yeah, that's right. Yeah, just go like on Tuesdays, I want this price for donut. Mark.
So I've used Pack, but from what I've seen of it, it is like a two-phase thing where you basically set up a mock of a service for your test.
Yeah.
And when you run your test, so you set up, if I get this request, you need to send me back this response. You run all your tests against it.
Yeah.
It records all the requests you make.
Okay.
The response it's sent, and then later back,
It goes and runs
runs it back
those.
against the
Yeah,
actual
okay.
service.
Yeah, I've not actually used it, but
And
that's...
there you go. That what you use, all your tests passed against your mocks.
Yep.
And then I just checked all those requests against the actual.
To make
thing,
sure that that's what
and
it comes out.
The response you got back is what
Yeah.
you were expecting in your mocks. So it is a bit like that. Where
Yeah, I mean, I could see that be useful.
One side and then
Yeah.
check that your contract.
They use a kind of two-phase approach
Yeah,
though.
that's
So
what it is.
Yeah.
as you run your test, you describe all your assumptions
Yeah.
when you're writing your test, and that creates a contract file.
Yeah.
So the idea is that contract file is then run against the server side to check it. So it's kind
Yeah.
of rather than
Kind of-
but I'm saying it's more of a,
Just take some work,
a
yeah.
one-letter test. It's kind of like two-letter tests.
Yeah, which wouldn't work in an environment where you've got this massive test environment
Yeah.
problem, test data problem. And this is kind of when you're building this application that has to be quite small and nimble, but then you've got this just massive thing like Salesforce or Azure. Has Azure changed its entire contract today? Yes.
Yes. Not a website. It's just yes.
Is anyone like, because I'm still hearing that the responsibility for mocking is with the people who are testing their code, rather than like the people who produce the service produce like a verified mock. They just test the contract there.
Well, in generally, like so, if say you're dealing with Salesforce, right? So you're building an app that talks to Salesforce. You can't say to Salesforce, hey, can you just stand up this every night so that I can, run my thing? Or, every time I say we're going to do a test run, can you just stand up a new Salesforce for us to play with?
Couldn't
So you
they do
can't.
a mock interface? Like
So yeah, so
part of
that's.
code?
But the thing is that if you've got 10 different teams building stuff against Salesforce, and one of them's in Ruby and one's in .NET, one's in Node and one's in something else, and you go to Salesforce and go, can you give us 10 mock implementations of your service to inject into a code? They're going to go, no. So,
Actually, they'll go, yes.
yeah, and it's going to cost you this much.
4
Yeah,
hours each to provision,
yeah,
and it will cost you a packet.
yeah.
It'll cost you more than
So no, generally, you know, if you are developing code and you need to mock out some other system, then you're going to build whatever mock you need to suit your purposes. Now, in a lot of companies, you might say, hey, look, there are 4 different teams all building the same mock against some internal thing. Let's sit down and collaborate so we have one that we can all use. But yeah, with this, you could then write a lot more unit tests with just, you know, any mocking framework, whether, you know, if you're in .NET, you know, there's a bunch. If you're in Java, there's a bunch, you know, and then it's kind of not a big issue. And that's I guess the point is, if you can go, right, our assumptions about the system are still true, then you can write tests at a much more of a code level, much more of a unit test level to go, look, you know, if I say to my abstraction over this service, get me a customer, here's a customer. You know, it's just not a big deal anymore. Yep.
Just to comment on your system diagram back at the start.
Yeah.
I recently discovered the Damian architecture from Maclennan,
Yep.
which inverts
All of it. Yeah.
everything.
Yes.
In, it treats all your dependencies which aren't your own code as external. Effectively, like the database there is everybody's external
Yeah.
party, so it makes that testing problem much more clear.
Yeah. Absolutely. You know, and it's more where you've got, and yeah, that's kind of, that's why business logic's like that. But it's fairly typical of how a lot of, you know, systems you sort of walk into look like. But yeah, there's a lot nicer ways to build a lot more vertical architectures. But you know, if you've got some, you know, say it's some system, whether it's a third-party hosted thing or something else, you've got some dependency on. But yeah, that's not an architecture that I want to build. Yeah.
Just the fact that the database itself can be considered an external.
Yeah, absolutely,
So
absolutely.
You can mock it out.
Yeah.
Have it as-
Oh, definitely. You know, if you're writing unit tests, yeah, you have some pattern, you know, whether it's a repository or, you know, whatever you want to call it, that yeah, you can mock. So at your unit test level, you can say, hey, look, I'm expecting something to come out that llooks like this, and I want to know, did you get something back that looked like that? Chris.
I was going to ask about how I test my stored procedures, but I won't. I found, I don't know if this is a bit of a weird case or not, but I found a requirement in the last week to set up sort of an early warning test.
Yeah.
It's something that I wanted. It was an external. It was the Azure. surprise, warning from
Early warning. Has the API changed?
No, not that.
Return true.
See, if the API changes, that's fine. That's simple with breaks.
Yeah.
Like, my build fails, that's okay. We can't, you know, we can't work against a broken API until we fix it. The usage data that you get back from them.
Yeah.
You're meant to get back sort of from UTC noon the previous day.
Right.
Sometimes it'll be 2 days behind or 3 days behind.
Right.
Until their own internal systems catch up. So I found myself writing what felt like an early warning test because it's not something that it affects our system, but it shouldn't stop us from actually shipping.
Yeah.
How would you best go about having that sort of thing? Because where I struggled with this was, yes, it's a test and I want this running as a part of my nightly build.
Yeah.
But I don't want this to report a failure because I don't want it to stop us from actually shipping.
Yeah.
But I want to know about it, and warnings, you know, well, there's not really the concept of a warning.
No, I'd put it as a separate build. So you've got your build that says, right, if we've checked in our code, we're going to compile that. We're going to run some unit tests. We're going to, you know, whatever, and spit out of that an artifact. And provided your tests pass, that artifact should come out and your build should be green. So you could have this as a parallel build. And that's kind of the way that I would approach a contract test. Is this something that we run, you know, and it doesn't need to be in line with our CI build. It can be something that's nightly or, you know, whatever your period of change is likely to be. So you could have that as a nightly build to say, hey, look, we ran all these tests against this thing, and yeah, it hasn't stopped our code from working. There's just something wrong over there. But something like that, I'd probably, if you've got some like operational dashboard, that's probably something I'd surface there. It's not a build activity so much as,
It's something
a big red warning light that says,
It's something that we
reporting.
need to be aware of so that we can let our customers know.
Yeah.
Like, hey, there's a problem. It's not us. There's just.
Have you built Upstash yet?
Sorry.
Have you built Upstash yet?
No, not yet.
No. So I'd put it there. I'd say, if you've got some, like a monitoring dashboard of your application, then that would be one of the triggers I would put in there. And it says, every hour, 2 hours, 3 hours, go and poll that and go, are you behind? Are you broken? Or are you happy? And because that's an operational thing. It's not a build's more about testing code quality to say, I've checked in my code, everything's good, we can release that. This is more of an operational thing. Hey, customers, this thing over there. Yeah.
But even having it run in the nightly.
Yeah, well, that means that, it's going to stop that's going to say your code is bad because someone else is having operational issues. It's not really a code quality thing. So yeah, I'd have some other dashboard somewhere else that says our system is healthy, but the things that we talk to are not. Yeah. Anyone else?
I just had a suggestion for the edge case.
Yeah.
If you're running into edge cases that you didn't account for when you did your contract testing, so you hit this third party, and yes, when they do an update to a customer, they check it again and it sticks. But in some weird edge case where the date of birth is, I don't know, after 1970, for example, then it fails.
Yeah.
We didn't think of that.
Yeah. So then you'd write a test for that.
Then you write a test
Yeah.
for that, and maybe you change your code to
Yeah.
integrate that scenario and so on. So it's almost like it's the same as you do testing anyway.
Yeah.
You do
It's like I've found a bug. I'm going to write a test to verify that bug, and then I'll write code to work around that. So.
Because you might have picked that if you did full integration testing. Like you might have just landed on that one as a chance encounter, but probably not. I mean, there's always going to be one that you have
Yeah.
found.
The thing is, if you can free your test team up from writing really pointless,
The thing is,
end-to-end functional tests. No, I'm talking Josh. Then they can go and do those really experimental exploratory tests. Over to you.
Well, the thing is that your test would actually pass. You would put in a post 1970 birth date, and it would actually pass.
Yes.
It's all good.
Yeah. So that's an exploratory
So you've
test.
actually got a test that passes. So your tests are actually.
Just like your unit test suite will pass
Yeah.
if you aren't actually testing with it.
Yes. The thing is that most testers don't have time to do that kind of exploratory testing because they're too busy trying to regression test all the things that should already work. And so if we can free them up from these really hideously expensive to write and run and maintain regression tests, then they can spend more time doing useful stuff that humans can do. Like just dig into this and tell me where it's broken. Whereas, a test suite will not do that unless you're using PEX or something to go and...
If I press these buttons, it
Yeah.
breaks. Why would you ever press these buttons?
So you say if you had a contract test that did the post 1970 thing, and that contract test returned from this third party system, it returned green, like everything was fine. But in production, it didn't.
But that might be a contract test you need to write. Like you might find that bug in production and then you go, okay, we're going to write a contract test to go, right, is it still broken if it's before 1970 or post 1970? They might be two tests, but they're only two tests, right? If we call before 1970, it looks like this, post 1970, it looks like that. Cool. This system hasn't changed as far as our assumptions go. Given that, you can, write your unit tests and whatever, working on that assumption. If that 1970 thing was a bug in Salesforce and they fix that bug, then your contract tests are going to start to fail. Why did they fail? It's like, they fixed that 1970 thing. Cool. We can kill that test and change our code because our assumptions around the world weren't valid because that thing got changed. So yeah, but you're not going to find those things with contract tests. You'll find changes in your assumptions, but finding that, if you put in a birth date before this, that's the job of an exploratory tester.
So you're saying basically that the kind of agility of testing against contracts outweighs the fact that you're now testing against what you assume the system will do.
But you always are. You know, like
One of the fundamental things is that tests can't prove the absence of bugs, they can only prove the absence
of the ones you knew about.
assumptions.
Yeah. But yeah, too many people spend all this time writing these hideous amount of combination of tests that are really delicate, and they never actually go, oh, what happens if my name is # star x1 -- drop table students,
We will be taking this.
Well, thank you for coming at short notice, and hope it was